Okay, today I will tell about running large language models at home. It's not like at home anyone can run, it's some dedicated hobbyist stuff. But like technically you can do this, and I will tell about kind of capable models. Uh, okay, let's talk about me, why this stuff is relevant, and what you can get. I have 7 years experience in big tech, and I have a lot of pet projects I do. I publish them on GitHub. They will be also found in Forgeo Mirror. I have at computer I host at home. I'm an AI enthusiast starting 2023. So basically, when ChatGPT started, I started using it. And let's talk about why we need LLMs at all. Basically, they can help you with writing a code that's not that capable, like you can replace programmers currently, but that's kind of good junior level developer stuff. You can use them in support. You can train LoRa or add some reg or add to context about some frequently asked questions, and you can replace like first level of support. So basically, you need escalation to next lines of support, but you can reduce amount of queries being asked. Um, this is actually like very good compression of all knowledge in internet and not only internet. You can fit it on some device, and you don't need if you want to make a search index, if you want to do this, you need a lot of compute power. With LLMs, you basically compress all that knowledge. This is compression with loss, so you have some hallucinations, some problems with it, but it's very incredible that you can compress this stuff and it will work. And also you can make large language models draft presentation for you. Obviously, I checked what's being written here, but yeah, you can use them to help with different stuff. Uh, there is way a lot of people are running large language models. This is running in the cloud, but you know that cloud is just someone else's computer. Actually, we have poster with like same words, and this is easy to scale. If you need like 10 times more requests, you get it, just pay 10 times more. You don't need to maintain infrastructure. You have like best minds that can be found in tech working on this. So like you can expect some kind of 24/7 availability. Obviously, sometimes they have issues as well. But if you compare that with like self-hosted stuff, if you get like out of electricity at home or you have some internet problems, it's unavailable. If you have this in the cloud, okay, yes, but you need some maintenance with infrastructure and stuff. So if you buy API for LLMs, it's very robust on how it's used. But problem is you surrender your data. Obviously, they will have some policies, some masking, maybe some like legal stuff. So it's not like publishing into internet. But you should know that by asking any cloud LLM, you're giving your data to some people, and it's their responsibility to take care about this data. And also, I would like to mention that size of models, it's matters a lot. So basically, let me tell about these charts, what they mean. If you have some model, you want to train it, you spend like ridiculous amount of compute on this. It's like millions, tens of millions, maybe hundreds of millions of dollars to train model. And basically, bigger model is, easier it to train. So like loss, it's how bad model behaves. You need to minimize loss. And you see that it's easier to do this with bigger amount of compute. And like data set, one of ways to scale model. If some small model don't works with your data, you just add more data, and you need bigger model for this to work well. And I would like to tell you about this website. Obviously, you may know about this. There is a lot of copies of this site. It's named LM Arena, and idea is that you have different prompts and you have results from different LLMs, and guys will score, like it's crowdsourcing. You score how good models behave on like different data sets, different like some maybe something that they are measured on. You see that's on top here, there is only proprietary models you cannot run locally. That's basically they're spending a lot of money to make them really cool. But if you open this website and scroll, you will see some models you can actually download and run. They will be not that's like good like this, but it depends on tasks you need. Sometimes you will find very good models and they will give you decent performance. There is different types of hardware you can run models. So basically there is CPU, GPU, and NPU. Let me tell about what's the difference. CPU, it's central processor unit. It's like general purpose thing. It can run any computations, but there is some limitations to like how optimal it can run. There is GPUs. GPUs are dominating this like neural AI and LLMs because they can process stuff in parallel, and parallel computing is what you need. And there is NPUs. NPUs, it's like very specific stuff for neural processing, but current state of it, it's that's like for big stuff, you'll still use GPUs. So for CPU, it's cheap because it's like it's general purpose. You can run pretty good CPU without like paying a lot of money. If you have RAM, you know that VRAM from GPUs and from NPUs, it's really expensive and like there is some crazy topology. But for CPU, you can use like general purpose RAM, and it's like cheapest RAM you can get. And also, if you think about architecture, those chips are mostly proprietary. And like I think only for CPUs there is some tries to make it like open hardware with like some specifications and maybe chips you can verify, like RISC-V architecture, for example. It's not that like top performance on large language models inference, but maybe in future, if there will be enough investment in this place, we will see some open architecture CPUs that can run large language models at scale. Obviously, it's slow, and you cannot use CPU for another tasks if you use it for large language models processing. There is GPUs. GPUs, it's like it's mostly used. If you go to some like proprietary LLMs in the cloud, they will use GPUs. If you want like really fast inference, you use GPU. It depends on which vendor you use. Like for NVIDIA, they have very streamlined experience. You just like open and it runs. With AMD, it's like it's kind of open, like open drivers, but it's like there is a lot of problems with drivers and infrastructure about this. Uh, Also, like for GPU, you can have a lot of different software available. And problem with GPU is that it has very limited VRAM, and it's kind of expensive. Like some cool build that you can run like big models comparable to cloud ones. You can buy apartment for that money you can spend on these builds. It's crazy expensive. And for NPUs, it's kind of promising idea. It's very efficient on power, so you will find them on laptops, on some like handheld devices, something. But problem is that they kind of small, like maybe 8 GB of RAM you will find, or maybe you heard about like AI Max from AMD. But problem is that on same chip, GPU is just better. You will get better experience. NPU is cool if you care about electricity being consumed. Uh, they have like very limited software. There is experiments like some cloud providers are making their own NPUs to compute to try to replace a compute from GPUs. But it's really niche stuff, and for like most of practical stuff, you will not use NPUs. You will stick either for CPU for cheap or for GPU for good performance. Also, about hardware, there is different types of memory. Actually, like memory throughput is bottleneck you will hit most of times. Any other stuff is also matters, but like memory speed, it's stuff you really need. For like a regular RAM, you can have hardware with up to 4 terabytes of RAM. It's really a lot, but it's slow, and it's like DDR4, DDR5, not bigger. You can have unified memory, and it's like cheap way to give it to GPU. But problem is like it's kind of what you can find on Mac hardware, on maybe on that AI Max stuff on different chips. But problem is that it's slow, and it's like it's kind of comparable by speed with regular memory. And you cannot have like 4 terabytes of unified memory. There is no such stuff. For 4 terabytes, that's like obviously server motherboards. They're expensive, but you can build it, and it's way cheaper than 4 terabytes of VRAM, because VRAMs on chips, it's like 24 gigabytes or maybe like 48 gigabytes, but not that much. And VRAM is really fast, and it's DDR6 or DDR7, but it's crazy expensive. Like you can have A100 or like that's Ampere from NVIDIA Ampere architecture. That's like 80 gigabytes. That's server GPU, but only 80. You can have like some maybe Blackwell series with 192 gigabytes, but it's still way less than you can install in regular server with like CPU. And problem is like for really good build with those GPUs, you need like maybe 8 of them or like 4 of them, and each such GPU is like $30,000 of dollars. So basically, it's not possible for a dedicated hobbyist to buy. You will buy apartment, not like 8 GPUs. Um, and also about trade-offs. This repository, it's kind of old, maybe already 1 year. It was built before I made my home rig. But what we did here, we compared different hardware and different models, and how fast they can answer. And there were comparison with like some OpenAI stuff. You can see ChatGPT 4.0, so it's like it's really old table. But there is basically you need to pick 2 of 3: fast, cheap, or quality. You can get fast and cheap, but quality will be not that cool. You can get cheap with good quality, but fast, no, it will be really slow. And you can get like fast and quality, but it will be not cheap. You will spend a lot of money on hardware.
I have a question.
Yeah.
So, where did you get these benchmarks from?
It's crowdsourced. Most of this data was get by me. So actually, I was renting different GPUs and running different models. There is some problems with this stuff. It's like it's really old, and I was using Olama because I knew about only Olama. But problem is it's not efficient. Like it's good for beginners. You can just start and it will work. But you get like some quality. You get like some speed penalty. You can use like Llama CPP or VLLM or LangSG or different runners. That would be better. Uh, but yeah, I published this stuff, and some people, like for example, for MacBooks, I not found where you can like rent and run it. So some of data were crowdsourced here. If you have some questions, you can like interrupt me after slide, and we will discuss a little. And after this presentation, there will be like some open discussion.
One little question.
Yeah.
What are the numbers, like tokens per second, or
Different models have different tokenization patterns. So that was symbols per second, because you need to compare apples to apples. And if you compare, like some model may have like bigger tokens, some smaller, and you need to compare them one to one. So like length of output was chosen, and like data set was half like English, half Russian. Actually, like I exported my chats with ChatGPT, picked some that I'm okay with publishing, and made this data set. You can run like any stuff, like any model. Basically, if someone is interested, you can take this repository, fork it, and change it how you want. Uh, so this is like my home server and cat guarding it. Actually, like there is some fun thermal throttling happening because that's this CPU is really power hungry, and when you load it to 100%, it makes like hot air, and my cat loves this hot air, so it blocks that airflow. That's like some hot stuff, but then it will become so hot that it's uncomfortable for cat. Cat goes away and this stuff cools down. I built like half of terabyte of RAM. That was made before RAM prices spiked. Now it's like if you want to build this from scratch, you maybe should choose like smaller amount of RAM. And actually, like I was just exploring, so I tried to buy like as much as I can. And actually, here bottleneck is memory speed, so you maybe don't need that much. Maybe 128 gigs would be like kinda good. I will show later which models I ran, and basically like if you open 800B model, that's like really huge model, you will get like 1 token per second, or like 1 token per 2 seconds. That's not speed you want, but like 800B, it's really big model, and it's like 64 core AMD EPIC. I bought it used because if you want to buy new, it would be like really crazy expensive. It's already like not the cheap build, but if you're a dedicated hobbyist, you may buy something like this or like some similar stuff, or maybe like not that much. And also I added a lot of SSD and HDD for like model storage and for data that will be processed. But like you can have a smaller amount of storage, and it would be kind of fine.
Question.
Yes.
So you said that it's kind of expensive. So how much was it?
Oh, a lot. I mean, if you're a dedicated hobbyist and like you don't spend on another stuff, you may buy. But maybe you shouldn't. Maybe it's like if you have wife who has like different. I'm single, so I can spend. But like if I had wife, maybe she will not like approve this stuff.
More than 3,000.
Kind of. Yeah. So okay, and what about firmware? Actually, like server motherboards, they have not only BIOS, they have stuff named BMC, baseboard management controller. And after I bought server motherboard, I learned about like how shitty there are. So basically, like there is kind of one or two vendors, and they don't care about security a lot. So they write some firmware that kind of works, but problem it's like very outdated. And if you expose this BMC hardware to like any network, it can be easily hacked. So after choosing this hardware, I knew that there is OpenBMC. So basically, different vendors, like different big tech companies, they acknowledged that, oh, BMC firmware is really bad. Let's start some open source project, and they basically like reverse engineered this chip and made some OpenBMC stuff. But unfortunately, for my hardware, it's not working. There is very limited hardware support for it. But if you buy some like some server for hobby experiments, maybe you should think about like which boards are supported with OpenBMC, because BMC it's really big security flaw, and you need to like mitigate it in some way. Like mine BMC, it's not connected to like anything. If I need it, I just use like link local. So I basically like I take my laptop, I connect it directly to the BMC chip, so I can speak to it, but I will not connect it to my router. It's like it's not cool. And like also for problem with this BMC, it's actually like controls regular Ethernet as well, and for some reason, like sometime it just like resets its configuration and goes to a mode where BMC can be accessed from regular Ethernet port as bridge. So it still can be hacked, and you need like some network segmentation and stuff, or maybe really like choose some board that supports OpenDMC, and you will not have some problems with it. Also about operating systems, like I was choosing between different open source operating systems. OpenBSD, some Debian-based stuff, Alpine Linux. Obviously, there is like a lot of flavors of Linux, and I will not like have place to talk about all of them. Let's start with OpenBSD. Why it's cool, but it's not good for LLMs. There is very small kernel. It's security focused, but it lacks optimization. It lacks NUMA awareness, so it's like nodes, like which RAM sticks goes to which node. And there is problems with NVIDIA drivers as well. So OpenBSD, it's like too pure to run actually like some large language models at reasonable scale. First, I started with Alpine Linux because it's like small attack surface and it's muscle based. But I found it's like sometimes it just breaks and don't works. Also, NVIDIA drivers is hell, and some like building from source it's common practice. Obviously, there is like different stuff. Like you can think about Nix, you can think about Fedora, you can think about like a lot of some mainstream operating systems. And like from that like bell curve meme where there is like very stupid and very smart guys that both choose Ubuntu server, I finally stopped with Ubuntu server. There is everything, it works out of the box. Yes, it's larger attack surface, a lot of unnecessary services. If you like update it and you get power loss, you have problems with it, you need to repair. But it kind of works, and currently I'm okay with this. Maybe sometime I will move to Zen hypervisor and run some like isolated virtual machines. But for now, I daily drive Ubuntu server, and it's kind of okay.
Question.
Yes. Why not
What
Nix
about
OS?
operating system? No, no, no. You said no NUMA awareness in OpenBSD. Is there like a NUMA topology in your server, or like?
Actually, there is like one NUMA node where, so basically, server has 16 RAM sticks, and also I previously bought AI Max PC from AMD. I was very disappointed of how bad drivers are and like lack of support on Linux. It's kind of there, but a lot of stuff, and it's not works. So like you have some like driver for XDNA, you have some kernel, but you cannot run LLMs on it. And also it's really slow. I mean it's kind of fast. It's like some MacBooks have same speed, but because I have 16 RAM sticks and have 8 channels for that NUMA, that's like some memory topology stuff. So basically, like 8 sticks of DDR4 is just faster than like stuff you can get like unified storage. So basically, like a lot of RAM sticks, just faster, and you get better results than AI Max or than MacBooks or like anything else.
What I meant is like for me, NUMA is when you, for example, have two sockets for CPUs, and
Yeah.
then you have like some memory is closer to one CPU and other memory is closer to the other CPU. So
Yeah,
do you
some
kind of
boards
see the line?
has 2 CPUs. Mine board has only one CPU. It's named AMD EPIC with end of P. P it's names that it's only single socket, but inside of like it's 64 core CPU, and inside of it there is 8 CCDs. I don't remember how exactly. It's like some chip, like some not processors but like chips, and each of the chips has 8 cores, and those chips they have like NUMA awareness.
I see.
So like I think maybe that's why it can operate with 8 channels at once, because each CCD can communicate with one RAM stick, and each stick has 2 channels. So basically, like best speed would be if I had 32 NUMA nodes, but those are like way more expensive like builds. And I was like thinking about kind of like comparable to like some MacBook or something. So I'm not building like lab grade stuff. So there is like some trade-offs here. And also with different software, there is like VLM that's good for GPUs. There's Llama CPP that's good for CPUs. And there is like Llama, LLM Studio. It's not good neither for CPU or for GPU. It's just good for beginners. You just open and it works. It gets lower performance and has like lots of unnecessary stuff. But if you want to just start, you can start with Llama. And then if you see like how slow it is, you can, I mean, it's not that slow, but you can just like get 10% increase or like 15% increase by moving to specialized software, to Llama CPP or to VLM. And Llama CPP, it's cool. It's like zero dependencies. It works well with quantized models, but batching is not cool because it's CPU. It's like it's very limited on compute. And VLM, it can batch requests a lot, so you can like have a lot of parallel requests happening, but it needs expensive GPUs. Yeah, and what about models I'm running? There is GLM. It's like this slide this presentation was originally taught like 6 months ago, but because in AI it's advancing so fast, there is like another top tier models, and some guys watching me will like tell in comments, "Oh, that's bad models. Like use this." Guys, I have like life. I don't dedicate it 24/7 to just choosing best of the best models. These models are kind of good for this time. That's like not top tier. Maybe some models perform better, but I want to run some actual stuff, not choose models 24/7. So I use for GPU, I have RTX 3090, and I use GLM 4.7 flash. It's quantized for 4 bits. Actually, like each weight is different size, and they're like previously when this stuff was just starting, there was 16 bits floats, but then guys found that it's better to pack more weights with smaller size, and that's why I use 4-bit quantization. And RTX 3090, it's Ampere generation, so it's like it's not that's new like Blackwell or something, but it's kind of okay, and for bit quantization works. And I am getting 116 tokens per second. On this model, it's 31B. So like B, it's billion, and there is different models. You can see like some 1B models or 8B models, but they're like very stupid. 31B, it's kind of okay. And like for CPU inference, I get only 15 tokens, but it's like 229B model, and it's like it's bigger, but like you see it's like 138 gigabytes. So I don't use half of terabyte. And if I use, it will be like way slower, maybe 2 tokens per second or something. And that's like some kind of middle point where you get decent performance and decent like it's smart enough. And here is example of how these models write a poem about my cat. That's cat named Bramble, and you'll see like this is GPU, and it's like really cool. I like how fast it answers, and like in ideal world, I would like to have this kind of speed, but like this is very small model. You will see that's like this poem is actually like some slope, but like it's cool. It's like it's cool how it generated this slope. And here you'll see same stuff with kind of like kind of more advanced model. It's also slope. It's like, but it's slower slope, and like it's kind of more like more smart slope. It's also a poem about my cat. Yeah.
Question.
Yes.
You showed on the previous model it was Llama CPP with GPUs. It works okay.
Yeah. I tried VLM, but because it's like it reserves some like 4 gigabytes or something for their stuff, it just not fits into GPU with VLM. And I tried some plumbing there, but it not worked. actually, like if you spend, maybe you should not buy CPU. Maybe you should spend same amount of money and on 4090 GPU that was modified from 24 gigabytes to 48 gigabytes. Or maybe you can modify yourself. Maybe you can buy chips and go to like Hackspace and like solder BGA. Maybe if you're that kind of guy, or maybe you buy it. Or maybe you have two 3090s. Actually, 3090s, you can connect them with NVLink. You can connect only two of them. Like for data center grade, you can NVLink more, like for full graph. But for 3090, you have this interconnect idea that if you use like, if you have 4090 or 5090, they will be in PCI slots, and these slots are really slow. It's like kind of RAM speed slow, and like, so basically for GPU for 3090 you have 800 gigabytes per second memory. It's very fast, and like for that's 16 sticks I have 250 gigabytes per second. It's a lot, because like that's AI max, it's 90 gigabytes per second, and another kind of memory it's way slower than this. But like idea is that interconnects are also like tens, like 20 or 30 gigabytes per second. And if you have multiple GPUs and you interconnect them, they will be slow. So maybe you should use bigger GPUs. But 3090, it's kind of sweet spot because you can find it on like Kupujem Prodem for 500 euros, and it's 24 gigabytes. So maybe if you are thinking about starting like some home projects and budget, it's like kind of 500 euros or something, maybe you should just buy 3090 and it will work. But yeah, VLLM not works here because of overhead. You can choose smaller model, but I chose that I will use Llama CPP. That's more capable. It's not that fast, but it's bigger model that I can fit in same 24 gigabytes. 24, it's like it's nothing for LLMs actually. You need way more. And let's talk about security. So you have that's baseboard management controller. It's actually ARM chip that works on your hardware, and it's kind of backdoor. So problem with it, you cannot neutralize it. Your board will not work. So if you can choose OpenBMC, please choose OpenBMC. It's really cool. Or maybe you don't need server hardware. If you buy 3090, you can install on your gaming PC and like daily drive it for games plus LLMs. In this case, you don't need to care about baseboard management controller because it's only server hardware stuff. Also, like some basics like of security. You need network segmentation, you need firewall, use virtual links inside of containers. If you want VPN, use WireGuard. It's very lightweight, and like it's only 4,000 lines in kernel. It's really cool protocol. You can use virtualization. You can use Docker containers, and also like if you use AMD Epic, you will have that's like secure enclave stuff. It's cool, and actually like if your threat actors is not NSA, maybe it's good to use it because it isolates hypervisor from virtual machines. And if you are using like AMD Epic, maybe you should use CVSNP. That's like kind of encrypted virtual machines that can be isolated from hypervisor, additional layer of virtualization security. So basically, checklist, it's like look at firmware level, look at OS level, software, and care about isolation. For firmware, OpenBMC is cool. For OSs, you can have good open source operating systems. Software, use it from trusted vendors, like you download Llama CPP or download VLLM. Don't download something LLMs.exe from like some crazy sites. And do network isolation and workload separation. Also about performance, about caches, latency, and stuff. There is Kiwi cache. It's uses So it speeds up generation of tokens in large language models, but it requires RAM, and you need like to have some trade-offs between how much RAM you are using and how fast it's going. There is some trick for CPU bound stuff. It's memory mapping. So you actually not loading everything in RAM. You memory map it to SSD, and sometimes it works good, sometimes not. But you can like fresh start model. It would be slower at the start because it loads weights from SSD to RAM. But it's only for CPU. But you can use it like if you want to to change different models if you want to try all of them. You can basically swap them without without meaningful downtime. It will be slow at start, but you can swap them and just start. If you use like full loading, you need like to read this whole file to RAM, and only after this it can work. And also batching and queues, it's good when you have GPU and it's actually here this mistake. I will blame Cloud Code for this. But yeah, batching it's working better on GPUs, not on CPUs. And yeah, you can basically process multiple queries at once. Also, some bonus content. There is Open Web UI. It's kind of more like ChatGPT experience. So you have like your LLM, you can add Open Web UI, and you can have some like maybe Python interpreter or some like store of your conversations on your server or something. Yes.
If I remember correctly, it's as open AI, so it's not really open.
No, you actually can download it. I'm
Yeah,
not
but
sure what about licenses. Yes, it's valid point. Maybe licenses is not good. Check it. Uh, if you don't like license, you can use Llama CPP. You can like maybe search for different projects. But my idea is that you separate your backend that just makes inference and stuff around it, because large language models experience, it's not only large language models, it's also web search, its ability to run Python code, its ability to like retrieve some files and stuff. And you basically need something around it. And this is like one of projects you can use. But if you know better projects, maybe you can make some presentation about it, research this stuff, and we will hear from you what is better alternative. Also, let's talk a little about RAGs. It's retrieval augmented generation. So you have knowledge that's it's tightly packed inside of model, but you sometimes have your stuff, and your stuff it's not baked in weights. And RAG solves this problem. It's retrieves information, like you have some files, and your model can ask, retrieve me something. It will search and give it to context. And when model generates, it will use this information. Also, let's talk about low rank adaptations, LoRa. Not mistake it with LoRa that's like for message sending. It's different stuff. Basically, this is stuff you can learn on, like you can make this stuff on your hardware. It will take some time, but you can like have some adaptation. You can add some skills to model. Uh, Basic way to change how LLMs behave, it's prompting. You change prompts, you change how it interacts, you change system prompt. But if you want like really change domain of, I mean, not like domain of model, but if you want to some specialized stuff and you have like good data set of request response, how you want it to work, you can use LoRa. You can spend some time on, so your GPU or CPU will make it, and you will use it via inference, and this will change like model's abilities a little. Yes, and there is also bonus about fine tuning and prompting. A lot of people know about fine tuning from like ML world. So like when machine learning was a thing, main idea was, okay, let's make new model. You have some data, you make model. You have new data, you relearn model. Models were small enough, you can run it on some hardware, like maybe on some like or your laptop or some server or something. But LLMs are really, really huge. That's like gigabytes, like hundreds of gigabytes, maybe terabytes of data, and it's like it's not possible to run them to make them from scratch on your computer. Some guys are doing something, but that's like millions of dollars at least, maybe more, like maybe hundreds of millions of dollars or even more. So you have two paths. You can do prompting, so you change system prompt and you change how model behaves, or you can use low rank adaptations. That's like two techniques you should use for large language models. And also there is very cool playlist about some mathematician made it. It's like it's discussing about how exactly this stuff works. I mean, maybe you don't need this information, but I found this really interesting to watch, and like it gives some better understanding of how exactly LLMs work. And that's all. Thank you a lot for listening. If you have some questions. Yeah, here is my contacts. You can like basically on any social network you can try with this name.
I know the question. So we have this. Oh, so it's the same. This name. Do you have like the source code for this presentation?
Yes, it's like you can go to my website. It's tgr.rs and then /home -LLM. Yeah, you cannot see it from here. Who knows? Maybe I do. No, it's not works like this. Yeah, there will be a link to my home website with this presentation. But like problem is that's exactly that server at my home. So if cat presses down button, it will not work. If there is problems with electricity, if I think, oh, now I need to reinstall Ubuntu server, I want NixOS, and then it not works, and like I spend 1 week for like debugging this stuff, all this time it will not work. So maybe I will send like some zip file as well to like some Telegram or some like decentral forum or something as a backup. And also I'm planning to download. Actually, we are recording video and we are streaming it on YouTube. I think we will download it from YouTube and maybe like take that's what was recorded on that camera, and I may also publish it on my website or on like some file sharing or somewhere else. Yeah. Uh, any more questions? Yes.
What do you actually use those two models for?
Oh, it's like hobby project. I try to use them instead of ChatGPT. I use it for different stuff. I write code. I do some.
How do you write code with them?
There is like I use a lot of cloud-based stuff because it's fast and smart. But sometimes you want to try like to use it, and I use open code. Also, I use these LLMs for some like data processing. So like I have some files or like some data or some like Wikipedia scrapes or some like Telegram chat experts, and I want to do like some intelligent action in it. I may like write some Python notebook and make it like connected network to this LLM API, and it goes. Also here in Hackspace, you see there is teletype. It's like it's AI teletype. You can like write something and it will answer. And this teletype uses my API that's like exposed over internet. But like this exact API currently is down because I changed something. It currently not works, but it's not working anyway. If you just open it, you need some plumbing. And if I do this, I will just bring it like back and it will work. So yeah, basically like I use it for substitution for commercial LLMs when possible, like as a hobby, as like some stuff to play with, or also like if you think about like privacy in cloud models, there is no privacy, and maybe you also you may need some like digital sovereignty. Like for example, ChatGPT is down, Claude is down, my model is working. I mean, like it's not happening a lot, but if for some reason they will like cloud providers may degrade quality of their models. They also have like some questionable business model about like unit economics. They're like trying to grow as much users as possible, and sometime maybe they will like some may go bankrupt. Who knows? Some may initiatize their service to make their unit economy works. Some may just roll out some update you don't work, or maybe they will like impose some ethical standards on models you don't like. With home models, you put your model to your HDD, and then if you want to use, you move it to SSD, and it just works. And you also can like you can spend a lot of tokens, a lot of requests, and it will not incur additional costs. I mean, you obviously spend while buying hardware, but you can then just run it, and you don't need to pay for API each time you use. And also, it's like kind of psychological stuff, like I'm spending $100, or that's like I don't want. But like with this, yeah, it'll just like work for 1 week, 24/7. Okay, I get some electricity bill, but it's not that, not that bad. I mean, it's also not cool, but yeah.
I wanted to ask you actually about the electricity. You monitor the consumption.
Yeah, like I monitor it in a way that I get the bills. But yeah, actually, CPU is 200 watts, GPU is 350 watts, each memory stick is 15 watts, and it's like 16 sticks. Each HDD, it's like kind of 10 or maybe something watts. SSD is also additional, some idle. So yeah, it's power supply units, it's 850 watts actually. And like if you load it both GPU and CPU 24/7, you'll get something like this.
But you don't load GPU 24/7.
I mean, some weeks it's maybe loaded 24/7. I mean, it's not like 24/7 for whole months, but if you have like a lot of data to process, you just like scraped something, or you just downloaded something, or you have your own files, and you want to run some some pipeline. You called it in a Python. You start, and this pipeline not goes to some API. There is no like request limits. There is like for Cloud or for API ChatGPT or for something, you have some limits on usage. And if you paid for tokens, they will burn after like you paid for tokens, but they will burn if you don't use it. But for this thing, you just start, and it works. Obviously, it will be not that fast. Like if you really want this, like in 1 hour, and you're okay to spend like $100 in this 1 hour, maybe you should use commercial APIs. But if you're okay to wait for some time, you just make it work, and it works. Yeah.
Yeah, about quality. Can you say like you use it for coding, right?
Yeah, it's not good. No, I mean it's kind of okay. Obviously, like big models from commercially available ones are better on quality side, but like it's kind of okay. So it depends. So I would not recommend it for like whole substitution. Obviously, if you are like if you can spend amount of money comparable for what you'll spend for apartment to buy just like 8B100 GPUs that will like degrade in a couple of years. In this case, you will obviously be able to run some like Kimi K2, for example, and it will be like kind of comparable. But for this stuff, there is like trade-offs. I mean, it's kind of okay, it works, but it's not that cool like commercial ones. And like, who knows? Maybe in like 5 years we will have some hardware that will be like comparable to what we have now. But also like AI models evolve very fast. So maybe like in 6 months, this stuff will be like outdated. I made it like I made this presentation based on presentation I got 6 months ago, and like there were already stuff that was outdated, so I changed it. Who knows?
So
Maybe.
you said there's like a good model. What's the problem with running it? Do you need more RAM?
Yeah. Like I need more RAM. I have half of terabyte, and it's not enough. And I need fast RAM because like this one, I use like 138 gigabytes only because it gives me 15 tokens. Imagine if I get 10 more times bigger model, I will have 1.5 token, and it's like it's very bad. So like you need a lot of RAM and you need a lot of fast RAM, and this is like way more expensive than the hobby can be used for.
So what would you say is like the percentage wise? What's the ratio between you using ChatGPT and your LLM?
It depends on tasks.
I mean,
If I
overall.
need, I will say like half and half.
Okay.
Yeah, right. Like for some tasks, I prefer commercial models over API or over like some subscriptions. But like for some playing, for experimenting, for hobby, for some tuning, something, this is like it's my hobby. I like that's basically main hobby currently I have.
Yeah, I remember the question. Did you run OpenClaw?
No, because of security implications. I mean, I have ideas about how to run it, but it's like it's very badly rape coded. I mean, you need a lot of strong isolation to make it work. Like this, for those who are out of context, there is some model like agent named OpenClaw, and idea is you give it full access, and like they say, oh, you don't need Docker, just give it like your credit card numbers, your email, everything, and just like open internet access, and it will go and like do anything. But problems with large language models, they cannot distinguish between data and like instructions. As control plane and data plane, they're like they try to separate them, but there is no reliable way to do this. And because of that, it can just go to some website and be hijacked by prompt injection, and then they will install like their backdoor on your computer, and it will like do anything attacker wants. And like you can imagine, a lot of bad stuff can happen. And like I know personally a guy who started OpenClaw, and there was like Telegram chat where anyone can talk to it, and he said, oh, I am giving bug bounty $300 for anyone who can hack it, and like in a couple of hours guy already prompt injected it and like get full access. So like it's notoriously insecure, but like if you run it properly, maybe you're if you like if you treat this as like as malicious code and give it good sandbox, don't give credentials, and maybe like isolate network, maybe it can work, but it will be like limited usability. But like for like maybe someday I will find a good trade-off between usability and security and run it, but currently I don't run it.
What is the difference between the speed for the VLM and SIGSpeed? Did you try testing?
Yeah, it's like one order of magnitude difference. So basically here, this is GPU, this is GLM 4.7 flash, and this gives you 116 tokens per second. This model is, oh, yeah. So this model is 31B. It's like it's not that bad. Big commercial models, they don't publish specifications, but some speculations it's like thousands of maybe 1,000 or more billion parameters, and this like it's like 30 times less. So this is on GPU. This GPU has like a 800 gigabytes per second or something, and you have this much tokens per second, 116. And for Llama CPP, you get 16 tokens. It's kind of this speed. And this model, it's bigger. It's like it's 10 times bigger or something. It's like this one is 31B. This one is 229B.
Yeah, but I asked if you do run the GLM or
Mhm.
VLM.
Ah,
And what is the comparison between
ah,
OpenCP and VLM for the same model?
I don't know, because this model don't runs with VLM on 3090, because VLM has their own like Llama CPP. It's like it's very performance. it's very like minimalistic stuff. It has very small overhead on infrastructure, but VLM needs more stuff to be loaded into RAM, and it's like it loads 3 gigabytes or something of some memory footprint of technical stuff that's not model, that's not cache. It just needs it to work. And same model I was unable to open on VLM. But like from what I know, VLM for GPUs, it's better than Llama CPP. Maybe we are talking about like maybe 10%, maybe 30%. It depends on model, depends on everything.
Did you try any other model?
Yeah, I tried different ones, and also important thing, you see like this kind of good speed. It's only because it's mixture of experts model. So basically, like this big model, but only small amount of weights it's activated at the same time. If you use DeepSeek, that's I think DeepSeek is not a mixture of experts. Maybe I'm wrong, but for DeepSeek there was like 2 tokens per second or like 3 tokens per second. Basically, how you can calculate speed? That's you for each token you need to go full model. So like for this 229B, it's for 8-bit quantization, it would be 229 gigabytes. And with like kind of same gigabytes per second, it would be 1 token per second. But here we have 15 because like first we have only 4 bits, not 8 bits. It's half smaller, kind of half smaller. And also we have like 1/8, so like 8 parts. Only one is activated on the same time. That's why we have 15 tokens per second. And that's why I'm using min-max M2.5. I'm not using here DeepSeek, and I'm not using Kimi K2. I could use them, but there would be like 2 tokens per second, 1 token per second, half token per second. It's like maybe for like some stuff you just run and forget, it's kind of okay. But you will be very disappointed. Like first, I thought it's good to have big models. Okay, it's slow, it's kind of okay. No, after like working with this, I think like really thing you need is speed. You can have like smaller model, but if it's fast, it's cool. So if you guys want, I recommend RTX 3090. It's not that expensive compared to like 4090 and 5090. You can buy it used, like it's obviously after for like it was used for mining or for like some bad stuff. It may not last long, but like I bought mine for 500 euros in Kupujem Prodaj, and you can install it on any computer. And like JLM 4.7, you will have 116 tokens per second. It's kind of sweet spot for like maybe not the dedicated hobbyist who can like who have wife and who cannot like spend money on hobby. Yeah.
Did you try to run the so-called small language model on such hardware? Which level of performance we will talk about if we run small model like 1B?
Oh,
Like,
I did this before this computer, like literally. This is different, like physically different one, but I had like similar MacBook M1, and I was running 1B model, but it's like it's way stupid. It's like it just starts like producing like okay, LLMs produce nonsense, but 1B model it's 100% nonsense.
I mean, if you try to run such kind of model on your Minimax, on your, I mean, Epic CPU,
We can.
will you receive like a millions of tokens per second? Or
There is 2 limit factors. There is memory speed bottleneck and CPU bottleneck, like compute. This one, so like there is 2 stages. There is second is named decoding, and first one I don't remember. So like basically one of them it's pre-computes like state of the model is big vector in like multi-dimensional space. It's like 5,000 axis or something. It's vector. It's like a lot of numbers that's all squared and summed. It's 1. So there is part where you assemble it from tokens, this vector, and there is part where you like GPT is generative pre-trained transformer. It's like self-transforming. So it's like it takes this vector and it transforms this vector to another vector that goes to different token. And there is attention mechanism where you have like each token attends to each. That's why you have squared, like you have tokens and they all attend to each other. That's like why Kiwi cache is important. Uh, it's named prefill and decode. Prefill, it's when you have text and it's compacts and you get vector. And decode, it's when you generate next token from what you have. So like if we run 1B model here, like if it not be 229 times faster, it would be like really fast, but not that fast because of compute bottleneck. Here memory is bottleneck, but like for very small stuff, maybe compute will be. But you really don't want 1B models. It's like they're very stupid. Maybe sometime they models evolve, and actually like small models can be better and better. But 1B models, it's like I mean it's not usable.
Yeah, I put a 4B model on this laptop, which is like 10 years old or 15 years old, so it works.
And what's token per second you get?
It's a 5, but it works.
Cool.
And it's not that stupid, so it's not total garbage.
Which model you're using?
Qwen 3, 4B.
Actually, Qwen 3 is good, but like I mean like 4B model. I mean try to use it like a little. You will see that's like compared to this.
Yeah, of course. But laptop, when I only have internet, it will be a bunch of help because I could Google something. Actually.
Yeah. Actually, like I recommend you try daily driving it and say what's your experience. Maybe Qwen is good, but because when I was trying this, there was like Llama 3 maybe or something was there, and it was like very stupid.
Yeah.
But maybe now, actually, like Qwen it's really cool. I don't know why, but like Chinese companies, for some reason, they produce high quality open source models. So maybe Qwen 3 4B would be kind of okay, and like you guys can try running on your laptops. Yes.
Yes, about quality. Did you try running benchmarks, quality benchmarks?
Yeah, this
And
here you can if you go to this link, you will find some quality benchmarks as well. But
I mean, like formal, right? Formal with like a score.
how I did this. You see, some models are here. Yeah. I remember. Why I discarded small models. There were bigger amount of models here. Actually, maybe because we are in browser, we can just open it. And there, I'm not sure where it is. So basically, there were like this was a list of models I downloaded, and like I taken a lot of them, and I did the benchmarks on my data set, and I manually taught for each model, each query, I get answer, but that was blind test. I was not knowing which model it is, and I manually said, okay, is it okay answer or is it shit answer? And models that give more than 95% of shit. No. Models where like shit was more than 5%, I discarded from here. And you see like smallest model that passed this test was 14B. But this time, like it happened like a year ago or something. And as I said, LLMs are like evolving really fast. So maybe now 4B models would be okay. And like, yeah, I encourage you to like do some benchmarks and some quality and some like daily driving. And maybe now they're good enough.
So there is some software for doing this kind of comparison.
I mean, I really like I vibe coded it.
I have a question. Do you use instructions abstract models are doing the best because they're not generating a bunch of text that is like a slog. It's going straight to the point, just giving me what I asked for and nothing else.
I had this idea, but problem is that you need to like load and load them. There is some solution for this, but I found that's like for that size that I use, prompting is kind of like a lot of times just prompting model is enough to make it behave how you described. But yeah, there is specialized models for like coder or something, and I think like open code. I mean, open code definitely could be used, and maybe like even with like 3090 or maybe like with laptop. But like I compare it to top tier models, and with top tier models you can have like multiple agents that work in background, and you just like check it from time to time. So like that's the different like weight category. That's they are like, also working, but like for top tier solutions, they are way more autonomous. Like they're way more capable than like just oh okay, I ask something, I get something, ask and that get. And also problem with like LLMs is that generating text is cheap, but like verifying what's generated it's very expensive. And I get problems. I let it made config. I started for Gary instance, but model hallucinated path to storage of files. And after I did Docker compose down, Docker compose up, all my files gone. So like mistakes can be really expensive. And like with lower size models, like you're just asking it to make this stuff. So
Which model do you use for the open code?
currently I loaded these two. Let me find. Yeah, GLM and Minimax. I switch between them. Sometimes I use Minimax if I okay with waiting and maybe with more autonomous way. But for like response request with like where you babysit it, it's GLM is better because it's like it answers faster. But like for interactive sessions where like I run them on laptop, I mostly use commercial ones. Like currently I'm driving code a lot. But these models, I like them when like you send some request and it spawns agent inside of container that's like it's isolated, and it works on its own. So it's like it downloads your repository and changes something and makes pull request. You can prompt open code to do this, and like that's how I currently use open code. But like you can also, I think you can use it locally as well, but because like commercial ones are more streamlined, that's I prefer them for like where like time is valuable. I prefer commercial ones. But when I have time for experimentation, or like I want to try something, or like some hobby stuff, I use these models.
Why do you use pull requests? Why is it more
I don't want model to be able to push to main branch. I disallowed it. I made different account, and this account don't have access to pushing to main branch.
Do it in the IDE, right?
Yeah, but idea that you have spawning autonomous agents. You just give it something, and you give it like dangerous skip permissions. You have it contained inside of like isolated environment, and like it works on its own and gives you pull request.
But you can run VS Code in an isolated
Yes, and there is like some solution for running them on like Docker. But like I made fun of that guys because their instruction says, okay, pass Docker socket inside, and Docker socket is effectively root on host. So like uh, cybersecurity, I think like experience from working with this stuff, cybersecurity currently is not that valued by like this LLMs community. So I think if you can melt security with AI, with LLMs, you get like really cool results.
How I do it, I just have a VM.
Yeah.
And I use a remote extension for VS Code. You can do something like that.
Is it possible to control your computer through this extension? Why?
I hope so.
I use there is VS Code in browser, and I use this stuff. Currently, I'm stuck with this orchestration. I tried Kubernetes, but then I hated it, and currently I'm stuck with Docker Compose, and maybe I will do like some scripting or something. Maybe I'll do Kubernetes, who knows? But yes, like for spawning, actually, like if someone knows good like cloud-like experience with own hardware, like please tell me which hardware you use. Like I mean I need like some lambdas and then like some S3 storage and like some DB as a service and like stuff like this. Currently I'm doing this all manually, but maybe there is some good like own cloud solutions. Like if you know some.
Maybe Coolify, but that was like I haven't checked it in a while.
Like I made some research and like stuff I found was missing something. Like maybe they don't have lambdas, maybe they don't have VMs, maybe they don't have S3, maybe they don't have them all. As I remember, OpenStack was not like that ready for this, like out of the box at least. Yeah, but okay, let's take a look. Maybe this is what I need. Yeah. Do you have more questions, or we can end this presentation? Okay. Thank you guys so much.